Okay, is this the one?
Yes, we finished
Voltage?
that. Here.
Okay, this one finish, huh? Up to here finish.
No, here not finished.
Okay, this one not finish. Okay, it's okay. Then we'll start on the back side from here. So okay, so see here. Did I explain to you what is voltage, loaded voltage divider?
No.
Okay, so let's start from here. So suppose if I just remove distance, okay, just ignore this one and think these are the bus out, open ports. Your white circles you can see, these are the open ports here. It's like we can connect any load here. It is like that. You can consider it like you have power sockets in your room, in your house, where you can connect the powers. It could be a charger, laptop, mobile, or tablet, desktop, or whatever electrical appliances you connect. It's like that. So initially, that the ports are open. There is nothing over there. So there is an open port. You can put something over there. So it is without load. So this is a simple circuit. When I remove this one R3, you can see it is a simple series circuit. And if I ask you how much is the voltage available at point A, yani here. If I say point A, you know that I am talking about the voltage between point A and ground. So how much voltage is there? So yes, you will agree that the voltage across R2, am I right? Will be the voltage which will develop there. Is it right, girls? This much of voltage will be available here. So yani I'm saying V2. So V2 you can calculate by the formula which we called voltage divider. So because it is a series circuit, so we can apply a voltage divider. So we can say R2 over RT, RT any what? R1 plus R2 because it is in series and multiply by VS. So this is what without load, So we can say this is a voltage divider without load. Now girls, what happened if I connect the load to this circuit? Okay, so yani if I remove this one and I connect this R3 there, yani some load is connected. So R3 is what? A resistance basically, which any load can have basically. So it is now connected. So once it is connected, you can see that the voltage which was earlier developed between point A to ground will change now. It is because of the overall resistance is changed now because R2 is in parallel with R3 and this circuit now no longer as a series circuit, it is a combination circuit. You can see because of R2 and R3 is in parallel. So if I ask you again, girls, find the voltage, yani VA, okay? So this one I could also say this is VA, yani voltage at point A and ground. This is called VA, okay, which is same. Now here again, if I ask you now calculate VA, so girls, it is very simple. First of all, we need to simplify our circuit, okay? We need to find its equivalent. And how can I find the equivalent? We can find the combination of R2 and R3, yani equivalent of these two. So if I redraw this circuit will be look like that. One resistance and other resistance, this one, okay? This is what R2, 3, and this is now R1. This is point A, which was that over there. So now I can apply voltage divider. So if I apply again voltage divider, so the formula will change to R2, 3 over RT. And what is RT? Because both are in series, so it is R1 plus R2, 3 multiply by VS, same. So you can see the difference in these two formulas. First one is called unloaded voltage. This one is called loaded. This is the difference between these two, loaded and unloaded. Is it clear?
Yes.
Doctor, could you repeat?
Which point I should repeat? Tell me.
The last point.
So here I find the formula. So both formulas are clear to you? This formula and the another one, this one? Both are clear?
Yes, clear.
Okay. So the first one is without load. Okay, this one is without load, yani when R3 is not there. So I can also say unloaded. And the second one is with load, yani load is connected. Then we apply this formula. Clear? So this is something basically. Now let's see another picture. Things will be more clear to you. Another picture, yani another slide. See now. The first one is unloaded. Second one is loaded. Both are voltage divider. Voltage is dividing here and here in both the cases, R1 and this one and R1. But this is unloaded, this is loaded. So picture clears? Any doubt here?
Yes, miss. Yes, Doctor.
Clear, right? So, but the difference is that whenever we wanna find here V out, okay, we need to consider their combination. But in this case, if I wanna find V out, simply it is equal to V2 because of there is nothing connected here. So it's simple voltage divider, but it is combination circuit, and we need to find first R2L, any parallel combination. That's it.
Doctor, how did we know that the circuit is loaded or not?
Now it will be given to you, no? If it will be given to you whether it is loaded or not. Okay, so if it is given, you can see this one. It's there saying. So it will be mentioned in the question itself. See the question, then it will be clear.
Okay.
Okay, see this one. So if question come, it will be coming like that. So determine the loaded output voltage divider. What they are asking? Unloaded output. So when I say unloaded, and you can see RL stand for load, and what they are asking first, unloaded, yani without RL. So what I need to consider, I will ignore this one.
Yes.
Because unloaded, they said unloaded, there is no load. So class, when there is no load, so do you remember the formula, how to calculate the voltage at that time? Okay, just calculate. Yani V out at that time will be the same as the R2 voltage across R2. Is it correct?
Yes.
Okay, so just calculate how much is the voltage across R2. That will be the unloaded voltage. Any without load.
That would be 3.40 volt.
3.44. Okay.
No, volt, I mean.
Volts. 3.44 volts.
No, not 44, just 40.
Just 40. 3.4. All right, 40. So V is equal to 3.40 volts, which is
The unloaded.
Unloaded. Now, second part. This is part A, yani half of the question. Part B. Determine the loaded output voltage for the voltage divider for RL is 10 kilo ohm. So now we need to consider this one, and we have given this is 10K. Okay, calculate now again. Because this time current is splitting because of it is a combination circuit. So R2 and RL current will be different. So overall voltage we will be finding by the combination of that. So first we need to find the combination, any parallel combination of R2 and RL. Then we will be applying again voltage divider formula, as I explained earlier. Okay. 58.
2.57.
Okay, 5758, almost closer. 57. This is what? Loaded.
Loaded.
Bus. This is something. And can you see the difference between the voltages now? So loaded is having less voltage. Loaded voltage is less than the unloaded. Correct?
Yes, doctor.
Yeah, it's because of, one more element add in the circuit which is consuming the power, which is reducing the voltage across this terminal. This is loading effect. Because of it, it's less. And you know that because of two resistance, whenever two resistance are in parallel, so overall resistance will reduce or not? It will reduce or not? When resistance are in parallel, so the total resistance will reduce or not? Because you can see both of are 10 10, 10 10. So when you calculate R2L, so how much that was? It was 5K, and it reduced. So when it reduced, simply, this will also reduce voltage here. This is the effect, okay? And unloaded is larger because of, at that time, we considered 10K. But when we connect one more, so it reduces it. This is the reason here. This is the type of questions for the loaded and unloaded, okay? So this is the answer for that. Okay, let's see. What is the voltage across R3?
Doctor, first
Yes.
we find the current. Can we say the current total, it will be Vs over R total?
But do you know R total?
Yeah, no, we will find it.
Yeah, you can do it this way.
Okay, thank you, Doctor.
Okay. Yeah, Mariam, it is 8.8 volts. So yeah, it will be same as R2 definitely because they are in parallel. So if you calculate V2, if you calculate V3, they are gonna be same actually. But how you will calculate, this is the point. So as Fatima said, can we calculate the total current? So you can calculate the total current, no problem. So total current will flow like this. Then it will come here. After reaching here, this total current will split into two parts. This one and this one. So it's up to you how you want to approach. So if you calculate total current, then you need to apply here current divider so that you can find the current, then you can calculate. This is also possible. Or the way which you did last slide, that is maybe more simple. Just calculate R2-3 combination and then simplify it. Okay. So what about others? Mariam calculated 8.8 volts with the question mark. Yani not sure. 10.10 volts. Oh, you are sure? Okay, because meaning of question mark, what I know, it is like we are asking. It is not clear. Or maybe question mark is a unit. Everyone use question mark. Okay, so Shahad is getting 8.10. Okay, RT. Okay, Shahad is getting 178. Okay, but see, do you need R total? This is the point. You can calculate. I am not saying no. Okay, after RT, what will you calculate? IT. So calculate the IT plus. So IT will be flowing here. then you need to calculate what? I3. Okay, go ahead. How you are calculating? What about others? Only 2 students give the answer. 8.8 and 8. It's the same question which is in the previous slide, by the way. Isn't like that? So who is going to solve this mystery? We received 2 answers, 8.8 and 8.10. Mariam and Shahad. Bayan is also getting 8.10. Okay. Okay. So all of you, those are calculating. How much you calculate R23? R23. Mariam, Shahad, Bayan, all. 387. Okay. Okay. So, bus, if you calculate this one, this way you can calculate. And Fatima, and what is the another way? You want to simplify it. What is another possibility? What do you think we can start? Tell me. Maybe we will learn something new. Do you think any other way?
Doctor,
Yes.
it is the same if the question said what is the loaded output voltage, right?
Yeah, it's same thing. Yeah. Because this is the same kind of basically. So, but if we are saying a loaded, so rather than saying that at that time RL R3, you will see there RL, which is clear that this is load. This is the. Even in general, Fatima, it's depend upon the connectivity, how the resistances are connected together. Can you find any other way which you can get it? Yani, what is the first step? Do you think here 2 resistance are in series?
We can we say V3 equal R3 over RT multi VS or not?
What is that? I'm writing. What is
That
this
low
question?
in serious low.
Series no.
I will write it.
Okay. You can write. You can use pen. You can write on the screen. You can use your pen. You go to the annotation and then you can write it. Are you not taking much time to solve this question? Or if you are not solving, khalas, leave it. It's so simple. It's just simple. I'm not asking very good, big deal here. But no one is responding. R3, I'm asking here how much is the R3. So in order to find the R3, you need to find first total, yani R2 and R3, then get it. So it's so simple. I cannot wait here more. So it's just finished. This is the answer. Next is load current and bleeder current. What is a load current? The current which flow in the load is called load current. The current which is left behind after subtracting the total after subtracting the load current from the total current, it's called the bleeder current. Yani, what is a bleeder current? IT total current minus IRL1, yani current through load 1. Where is IRL1? This is the load. So we are connecting a load here at the point A, which is the current here IRL1. So we are subtracting that one. We have one more load. Its name is IRL2. Okay, the current is there. It is connected at point B. So two loads are connected this time. So two loads having two currents. So if we subtract the total current, these two load currents from the total, the remaining current, which is here, you can see I3, is basically the bleeder current. Okay, like you can say total current is coming here. It's split into two parts. One is the load, which will go here, and another one will come here. Okay, so this will again split into two parts. One will go here, another one will go here. So this is something, yani this is the load current, this is the load current. After subtracting the load current from the total, we are having this I3. This is called the bleeder current. All right, now can you find all the currents? So find the currents now. All right, go ahead, find one by one all the currents and find the bleeder current as also. IRL1, IRL2, IT, and bleeder current. How you will approach? Yes, Fatima, what do you think? If we have this picture in this circuit, how we will start? Should we start parallel or series, or what is the way? What do you think now? Tell me. Maybe your point will clear here. Parallel. Now, why did you choose parallel? Which parallel first? From where you will start? And you also need to draw the simplified circuits with every step. What is the first step? Tell me. Who will tell? Ashwaq, Al-Harbi.
Yes.
Yeah. What is the first step? R2, R3 and RL1 parallel. R2, R3. R2 and R3. Okay. Ruba, why do you think R2, R3 and RL1 in parallel?
I don't know. Maybe because they are.
Then who will know if you will not know? The one who is not studying electronics, he can tell. You should tell. You studied already, you are studying. And there must be some logic if you are saying. So what is that logic?
I mean that I need to find R2 and R3 and RL.
Okay, but you are saying R2, R3 and RL1 in parallel. So if they are in parallel, are they following the basic rule of the parallel circuit? Which is they should be connected between two common nodes. Are they connected between two common nodes? Yes, Mariam. Go ahead. Okay, Jana, you can start. Yeah, Mariam, what is that? You said R2 and RL1 in parallel.
Yes.
And Lena is saying RL1, RL2 and R3 in parallel. No, see, because if this concept is still not clear, so definitely you people are not not going to have a full marks in the quiz, because it is a parallel concept. And what is the basic point for the parallel? They must share common nodes. must be connected between common nodes. So like Lena is saying, or Mariam is saying, or what is that? Must they, or maybe name this up. If you are saying that they are connected between the, so did you are they connected between the common nodes? Okay, see, this is the point here. Okay, where R3, RL2 and R2 is connected. Okay, now what is another point where we are having common point?
A.
A. So A is the common point. Are you any from R3 or RL2, any one of them are connecting another point on another end here?
No.
So khalas, why are you going to A? Come down. What is this?
The ground.
Okay, so ground is a common point here and ground is common point here. Yani it means is that they are joined.
Yes.
So R2, one node is B, another node is the ground. Yani they are connected in parallel. Why are you dragging R2 in this concept? It is out of this point. They are,
R2 with RL1.
leave it, RL1 not with RL1.
Okay.
Because the another node of R2 is B. This RL1 is connected with the B?
No.
No. So don't discuss that point for now. First solve this one. R3 and RL2. This should be your first step. Clear? Go ahead this way. Calculate R3 L2. Just give the name RB because we are calculating the resistance at point B. So give the name RB and calculate their parallel combination. Tell me quickly how much it is.
5.8 kilo ohms.
5.8 kilo ohms. So can I draw this circuit, just skipping another left side and just drawing, this is point A, this is point B. Now this is the ground. So this is point, as I said, B, this is A. So I am interested to know how much is RB. RB. This is same R2. This is same R1. This is now here. So I simplify the circuit. I calculated RB. So how much is the RB, as you said?
5.8 kilo ohms.
Okay, 5.8. So RB is equal to 5.8 ohm or kilo ohm. Kilo ohm. Okay. So is it clear? How did I get this circuit step 1?
Yes.
Okay. Can we simplify further this one?
Yes.
Okay. So what is the next step if I want to simplify further?
R2 with RB.
R2 with RB. So can I give the name RA because I will be calculating here something like that. Okay. So or you can say even don't say, give the name RA. Just give RB2. RB2. So second step. I'm using again blue color. Maybe it's clear. So I'm just keeping left this portion, battery portion. Okay. It should be clear to you what I am drawing. This is A. And here now we will be having a single resistance and another one is this one. Okay, so this is, let's say this is RB2. RB2. Okay, how much it is?
12 kilo ohms.
12 kilo ohm. But by after adding this one. Okay.
Yes.
Okay, so this is RB2, that is 12K. Up to now, everyone clear or not clear?
Clear.
Okay, so once you reach here, what next? Can we simplify further?
Yes.
What is
RB2 with RL1.
RL1? Okay, so can we give the name RA because this is a point A?
Yes.
Okay, this is our understanding. Anyone can give any name. You can give Arwa, no problem. Arwa, or it's just levels. Okay, so third step. Okay, just use the same color. Third step, and blue color is okay if it is visible to all of you. So this is something now this way. Okay, just a minute. I think I can open whiteboard. Okay, clear now? Visible to all of you now? Very much clear up, right? Okay, so now,
Yes, Doctor.
all right. So now we can just write the values. This is R1 and this is, now I am saying RA. So the how much is the RA, girls, which you get it now?
10.7 kilo ohms.
10.7. Okay, 7.7 K. All right, now what is that? Actually, I need a total current. So can I find now total current after calculating the RT? What is RT? Fourth step should be so simple. This is the battery and this is a single resistance with RT. I can calculate IT, calculate the IT and RT now. RT is how much? Total, huh? Because now RT will be what? R1 plus RA because they are in series. Correct? So it is 22.7 K. Now calculate IT. How much is the battery?
22.7.
No, what is the unit? How much is the battery? We need to find IT.
The unit 24 volt.
24 volts battery is there, huh?
Yeah.
Okay, so calculate the IT now. 24, 25. Okay.
24.
Okay. Calculate the IT now. How much IT you are getting?
1.05.
1.05 milliampere, huh?
Yes.
Okay, so this way we calculate the total current up to now. Clear to all of you? This is total current.
Yes.
Okay, so now girls, actually I calculate total current. I need to calculate the different currents also. So now see, out of these pictures 1, 2, 3, 4, I can use any one because you know that all are same. It's just a simplification, you know, one by one. So which is more helpful for me? Okay, after knowing is IT, can you tell me how much is the I1? See, the time is how much? Yeah, quickly we have time. We can finish inshallah.
The same
I1.
because it's in series.
Same, correct. Okay, very good. It is gonna be same. Okay, so can I consider this picture 2, which will say this is the IT which is flowing here, and I am interested to find this current and this current. So can I apply current divider here so that I can find IRL1? IRL1. Is it clear concept what I am trying to say here?
Yes.
Okay, so calculate IRL1 now. Apply current divider formula and calculate IRL1. So do you remember the current divider formula? This is IT.
Yes.
Okay, this is IT. And we have to find IRL1. Tell me the formula first. What is the formula? If I want to find IRL1, what will be the formula? I will write.
RT over RX.
In this circuit, what is the formula? What is RT? What is RX? I don't know.
RB2.
Yeah.
over RB2 plus RL1.
बस RL1? No.
No, RL1 over RT times I total.
All are wrong. See, whenever, listen, maybe you will get this time. So IT is splitting into two parts, divided into two parts, this one and this one. And I want to know how much is this current. Which one? This one. I want to know this current. See the formula. Because you people did not memorize that one. The problem is that. So
RB2.
when I want to calculate this one, I will consider the another resistance in the numerator, which is RB2.
Yes.
RB2 over
RB2
plus
plus
RL1.
RL1.
This one, RL1. So this is what? RB2 plus RL1. This is the way. Multiply by the total current, which I want. No, I know that it is going to be split into two parts. Khalas, now you have to calculate this way. Calculate and tell me. .55 milliamps. Okay. Check others also. How much is IRL1? Manar is getting 0.55. How much you are getting? Okay, 0.1125 milliampere. Okay, so two students are getting, Roba and Mariam is getting same. All right, Manar, check your answer. So answer is 0.1125 milliamps. So we can consider 0.112 like that. Okay, so it is like 0.112 milliamps. Khalas. So we calculated one load current. Now what we need to find the another load current. Okay, so this way we calculated this load current. Okay girls, now which picture I need to consider? Okay, you know this one, this current which is here. Okay, it is gonna be split into two parts again. If I consider the original picture, okay, so maybe I can bring that picture here. Just give me 1 minute. This, okay, see. Okay, just copy and okay, visible to all of you?
Yes.
Okay, why it is okay. So girls, now so we have calculated here using different color. Now let's say green. So we already know now that two currents, which is this total and now IRL1. Now I am interested to know this current, which is IRL2, yani second load current. Okay, so how can we know? So we have this is the node A and this is the node A, correct? So we discuss this one and we find this one. Now if I found this current, this is the same current which we called I2, am I right? Which will come here, I2. So is there a way to find the I2?
Yes.
Can we apply here KCL? What is that? Kirchhoff's current law. Yeah, Mariam, correct. So IT, yani I2 will be how much, girls? I2 will be
0.94.
Yeah, Mariam already calculated in the chat. You can see So 0.938, or I can say 0.94. Am I right?
Yes.
Okay. So 0.94 is flowing here, and it is dividing into two parts again. If you look this way, my arrow direction, because I always assume this way, you know that one. And now I'm interested to know this one. So can we write again a formula here to know the IRL2 specific for this situation? Yani
Yes.
IRL2 is equal to R3 over, yeah, correct. R3 over R3 plus RL2 multiplied by I2. Correct, girls? Because I2 is splitting into two parts, and I have to calculate that one. So calculate that current also, which is IRL2.
55 microamps. Amps.
55 or 0.054 milliamps, or 55. Okay, yeah, 55.
55 micro.
Yeah, micro, it will be. Okay, let's just take it in milli because calculation will be easy. That's why I'm saying. Otherwise, yeah, we can go for micro also, no problem. But because all total IRL1 is milli, so better to consider in milli, which is 0.055 milliampere. Mariam is calculating like this. So it is same?
Yes.
This, okay.
Same.
Same. So I can say now IRN. Just a minute, also. Yes, sorry. So yeah, so how much we calculate? IRL1 is equal to 0.05. Is it 55 or 54? How much I consider?
55.
55 milliamps. Okay, girls. Now, so we calculated, if you just look this picture, so we have calculated IRL1, IRL2, both the load current already calculated. Can I find the bleeder current, which is I3, yani this remaining current? Can we again apply what? KC,
0.
yeah, current Kirchhoff's current law. So I3 will be how much? You can calculate it. Or I total minus IRL1 minus IRL2, you can also get the I3 same way, which is the bleeder current. Okay. Check how much it is coming also. I3. Both way will work. Either you can apply KCL at node B, or you can apply I total minus IRL1 minus IRL2. Try both of them and check. Okay, so 0.88. So Mariam is applying KCL. Alomari, you can apply any other way to check this one. Any other, yani, the formula which is mentioned in the slide. Total minus that one. So this way we have calculated all the currents. Any question? Any doubt?
No.
No, clear.
Clear, right? And keep in mind, don't think this question is taking too much time, because I am explaining too much. That's why this question is taking too much. Otherwise, if I go fast, it is not, this question will not take more than 5 minutes. because I am explaining, I am waiting your response and all these things. If I have a whiteboard in the class, I can quickly solve all these things. But here I am waiting for your response also. That's why it's taking time. Otherwise, it's not so easy. It's just easy. But once I just go these steps, so I need a calculator. I will multiply and keep drawing this one quickly. This is something. Okay, so this is the way, and we have calculated all the currents. And see, so what is the important point here? The drawing, redrawing is very important in this situation, because redrawing is telling me which circuit I should consider, where it is, current is splitting and all. So it will take only, seconds to draw. So once you are practicing at home, you just consider it. Okay, so can I remove it? If you want to take a screenshot, you can take it. What is 0.38 ampere, Mariam Tariq? How you are getting? Mariam, how you are getting this much? 1.05 minus 0.12, 0.155. No, Mariam, this is not 0.55. It is 0.055. The third one. 0.055. Eagle eyes. Must have eagle eyes. Okay, just minor correction. Yeah. Okay, you have taken. So just I'm removing all, and we are to remove clear drawing. Just a minute. All right. So this is the way. So I think this is 350. Do you have next class, or this is the only class? So at least I can finish Bridgestone. It's just simple, one slide only.
I don't have a class.
Okay. I hope no one will have in class now. So it will, I think, just let me check how many slides are there. One. This is one. This is the same. But yeah, it's two slides there. It just so that we can start theorems from the next chapter, next week, inshallah. All right, so see now. So guys, next is Wheatstone bridge. The name of this circuit, which you can see here, is called Wheatstone bridge. It is forming a bridge basically. That's why the name is Wheatstone bridge. Okay, so see here how it is there. So this is a common point. This is a common point. Okay, where this R1 and R2 is connected. R3 and R4 is connected, and we are taking output here. Yani we can connect any load here. It is something like that. So here is R2 is having arrow. What does it mean? Having arrow on the R2.
Variable resistor.
Yes, true. This is a variable resistor. Yani its value can vary, can change. Okay, R1, R2, R3 is basically fixed resistor except R2, which you can vary. Okay, so interesting thing is that here, by varying the value of R2, girls, we can change the output, which will be coming here. Okay, so the Wheatstone bridge consists of a DC voltage source, which is here, and 4 resistive arms forming 2 voltage divider. This is forming 2 voltage divider. What are the 2 voltage divider? See quickly here. One is this one. You can see, because this let's suppose I will give the name A, and another one is ground. 1 voltage divider. And what is the another one? Can you identify another voltage divider? With R3 and R4. Am I right?
Yes.
Okay, 2 voltage dividers. It is forming 2 voltage divider. The output is taken between the dividers. Frequently, one of the bridge resistor is adjustable, means it is variable. When the bridge is balanced, see, this is an interesting fact. When the bridge is balanced, the output voltage is 0. 0 when it is balanced. Okay, so what is the meaning of balance? Yani which situation, which condition this bridge will be in balance condition? So the balance condition says when the product of the resistances in the opposite diagonal arms are equal. Yani product R1 multiplied by R4 is equal to R3 multiplied by R2. When it is equal, at that time the bridge is said to be in balance condition. So we can say balance under balance condition, yani when the output will be 0, R1 multiplied by R4, yani this diagonal will be equal to R2 multiplied by R3. Is it clear to all? Balance situation?
Yes.
Okay, it's simple and easy to understand. It is a balance situation. Now see one question. So what is the value of the R2 if the bridge is balanced?
R2 times 330 equals to R1 times R4.
Supply the formula, yani diagonal multiplications will be equal. R1, this one, and get it. So cross multiply and get the value. How much R2 is coming?
384.5.
384.54. So this is the balance situation, and we will be getting something like that, 384.5. Okay, your value is more accurate. Yeah, I considered 384.5 ohm. But this is something. Okay, this is balance condition. Output will be 0. All right. So class, bus we stopped here now. Just let me check how many of you are present. So I will take attendance quickly. Just give me 1 minute.